In this tutorial, I'm introducing the concept of distribution. Distribution is sort of hard to get your head around formally, so let's approach it intuitively. Let's start with this. Suppose we have a categorical proposition like all S is P. Let's ask the following question. Do we know something about every member of one of the terms in relation to the other in this categorical proposition? So for instance, look at all S is P. Do we know something about every member of S in relation to P? And the answer is yes, we do. We know that no matter what S you choose, that S is going to be a P, which means we know something about every S. If you look at the diagram, you'll see why that is. The shading, which means empty, pushes all the S's into the P circle, which means no matter which S we happen to choose, we know something about it automatically, namely it's a P. Now reverse that. Do we know something about every member of P in relation to S? In this case, the answer is no, we don't. Why is that? Well, pick some member of P at random. We don't know whether it is an S, in which case it would be in here, or is not an S, in which case it would be in here, which means we don't know something definitive about every member of P. So what we say is, if you can answer yes to this question, then the term is distributed in that categorical proposition. So, for instance, to review, in the universal affirmative, all S is P, we do know something about every member of S, so we can say that in the universal affirmative, S is distributed. But we do not know something about every member of P, so we can say that in universal affirmative, P is undistributed, which means that the distribution pattern for an A proposition is distributed subject, undistributed predicate. All right, so now let's try our question out on the universal negative. Do we know something about every member of S in relation to P? Yes, we know that no matter which member of S we pick, it's not a P. That's something we know definitively about every member of S, so S is distributed in an E proposition. Now what about P? Do we know something about every member of P? Yes, we know that no matter which P we happen to choose, we can be sure that it's not an S. So that means that in universal negative propositions, the predicate term is also distributed. So that means that the distribution pattern for E is distributed subject, distributed predicate. All right, now consider particular affirmative. Some S is P. Do we know, back to our question, do we know something about every member of S in relation to P? No, we don't. We know something about some members of S, namely some of them are P's, but what about these others? We don't know about them, what relationship they may have to P. They may all be P's, or they may not. The point is, we can't say definitively anything about every member of S in relation to P, which means that in particular affirmative, the subject term is undistributed. Now let's reverse that. Do we know something about every member of P in relation to S in this categorical proposition? And the answer is no. By the same argument, we don't know, for instance, we do know about some P's. I mean, obviously, we know that some P's are S's, but we don't know about the rest. So again, we cannot say something definitive about every member of P, which means that P is undistributed in particular affirmative. So the distribution pattern is U, U. Now, if you look at the square of opposition, and you think about the relationships like contradictories, it certainly looks like the relationship is flipped. So in universal negatives, we have distributed subject, distributed predicate. But in particular affirmative, the contradictory, we have undistributed subject, undistributed predicate. The question is, does that hold, does that flipping relationship hold for the contradictories A and O? If it does hold, then it means that we ought to have an undistributed subject and a distributed predicate. So let's see if we can answer our question. Do we know something about every member of S in relation to P in the particular negative? Some S is not P. And the answer is no. We don't know something about every member of S. We only know something about some members of S. But we don't know whether other members of S might or might not be P's. So the first part stands to reason. We don't know something about every member of S, so the subject term is undistributed in the particular negative. But what about the predicate term? Now think about this. Do we know something about every member of P? On the first glance, it may seem like we don't, because there could be P's here and there in the P circle, and we don't know whether they're inside or outside of S. But here's the thing. Given the information that we have based on the particular negative assertion, we have sort of like an anchor in this X. So think about this X. We know that this X is an S that is not a P, and that is just enough for us to know something about every member of P. What do we know about every member of P? No matter which member of P you chose, it's not this S, if you see what I'm saying. It may be some other S, like if it happens to be here, or it may not be an S if they happen to be over here. But the point is, no matter which P we choose in this whole region of P, we do know something definitive about every one of them, and that is, it's not the X that's being named, as it were, in the assertion that some S is not P. So based on that reasoning, we do know something about every member of P, and so the distribution pattern is undistributed subject, distributed predicate, and the architecture of our square of opposition holds across the contradictories. So here's the pattern. Let's just identify the pattern more specifically. So here's the pattern. In universal affirmative, we have a distributed we have a distributed subject and an undistributed predicate, so the pattern is DU. In universal negative, we have a distributed subject and distributed predicate, so the pattern is DD. In particular affirmative, the pattern is UU, and in particular negative, the pattern is UD, the opposite of A, or the flipped version of A. Now, you might be asking yourself, okay, this is cool, and these patterns are lovely and all, but why do we care about this? Here's why we care. Because distribution explains some very interesting, deep logical properties of inferences, both immediate and mediated. In fact, what we're going to see is the third of the big rules for validity for syllogisms depends entirely on the distribution of terms. But there's more to it than that, because the distribution of terms and which terms are definitively exhausted by the relationship they have to the other term in the categorical proposition that we find them, that set of relationships determines a whole lot about which inferences are valid. Let me give you an example. Consider the immediate inference conversion. Conversion is valid for what? It's valid for E and for I. And look at the distribution pattern. Conversion involves switching the subject and predicate term. I think I tried to say switch and swap. It involves swapping the subject and predicate term. And what do you see in both E's and I's? When you swap the subject and predicate terms, the distribution of those terms in relation to each other doesn't change. So notice, if we were to switch out D and D, we still get D and D. So the distribution pattern is the same. Same for the two undistributed terms in particular affirmative, right? Why doesn't conversion work for A's and O's? Now that we know something about distribution, it's kind of straightforward. If we were to swap the subject and predicate term of a universal affirmative, we would actually be forcing those terms to be in distribution patterns that they don't belong in. So for instance, if we turn these around, then we get undistributed for the predicate term in relation to S, but now it's up front as the subject, and it's in conflict with the subject term of a universal affirmative. So that's why conversion won't work if you try to apply it to anything other than a symmetrical distribution pattern, like DD or UU. Okay, let's look at one more. Why does obversion work for all the categorical propositions on the square of opposition? So let's take an example and I'll show you how this works. Let's use no S is P. So what does obversion do? It changes from negative to affirmative. It keeps the subject term, it keeps the copulative verb and the quality, and it takes the complement of the predicate term. So we go from no S is P to all S is non-P. Now think about this. In the original proposition, which was an E, we have a distributed subject and a distributed predicate. And in the resulting A, the subject term, see this pattern here, the subject term needs to be distributed, and the predicate term needs to be undistributed. Now, look at the relationship here between these two complements. What's interesting is that if P is distributed in its relationship with S, then non-P is the opposite of that in its relation to S. In other words, if P is distributed in relation to S, then non-P is undistributed in the relation to S. So what does that mean? It means because we've taken the complement, it is undistributed if P is distributed, and by taking it and putting it in a universal affirmative proposition instead of negative, we've put it in a pattern where we have a distributed subject and an undistributed predicate. In other words, the distribution of the term in its relation to S in this original proposition is preserved, as it were, or at least if we take the complement, the distribution matches what it should be for an A proposition. And that explains why, at a deep level, obversion is a valid inference for E. We could make the same argument for the other three types of propositions on the square of opposition. In other words, we could show that each one of these involves changing the distribution of the predicate term to its opposite because we're taking the complement, and in every case it works out because that complement's distribution is at home in the structure of the proposition that results from changing the quality. That is quite a mouthful, but if you think through this, you'll see what I mean. Similarly, we can see why various other relationships work. I'm going to leave this to you. Check out contraposition, remembering that the complement of a term has the opposite distribution in relation to the same pair that it's with in the original categorical proposition.